Yeah, hello everyone. Welcome back to Mr. Exams Professor. So in our previous lecture, we learned what an AVL tree is, what balance factor is, and why only -1, 0, and +1 are allowed. We also learned that when the balance factor becomes +2 or -2, the tree becomes unbalanced. But a question arises: how does the AVL tree become balanced again? The answer is rotations. Today's class is one of the most important classes in the entire ADA syllabus. So if you understand today's class, AVL insertion and deletion become very easy. So let's begin. So students, I have written the matter previously without writing the matter with respect to the video. So I was suggested by some student that sir, you have to write it before without explaining throughout the video so that I can get some matter to for a quick revision. So that's why I have written what I have to explain before only. So please note that. So please listen to my voice, okay? So okay, let's begin. So today I'm going to explain about these things, like why rotations are required, the types of rotations, LL rotations, an example, and what you have to do exactly in the exam processes. So let's start. So why do we need rotations? So students, imagine a building. If one side of the building becomes much heavier than the other, what happens? It starts leaning. The same thing happens in AVL trees. So when one side becomes much taller, the tree loses its balance. So to restore balance, we rotate the tree. So balanced tree, like it's fast searching, fast insertion, and fast deletion. Now unbalancing tree. So unbalance the tree, height increases, performance decreases, need rotation. So when rotation is required, see, yeah. So when rotation is required, if balance factor is equals to +2 or -2, rotation is required. So students, remember, never rotate when balance factor is -1, 0 or +1. Only rotate when the balance factor is +2 or -2. So some types of rotations are LL rotation, RR rotation, LR rotation, RL rotation. LL means left left. So for RL, LR and RL we'll discuss later. So let's concentrate here. So these four are the only rotation in the AVL trees. Every semester questions comes from these four rotations. Today we will completely master LL rotation. Let's concentrate only LL rotation. So what does LL mean? LL is nothing but left left. So LL means the imbalance occurred because we inserted a node into the left subtree or the left child. So root, left child, left child. That the left LL means left left. That's okay. So root, left child, and left child. So then left to left tends to L. So for example, students, now we are going to build the tree step by step. So in the first step you have to write 30. In step 2, insert 20, which is smaller than 30, so it goes left. So insert 10. So students, can you see the left side becomes much taller? Now calculate it. Root is equals to 30, left height is equals to 2, right height is equals to 0. So balance factor is 2 minus 0 is equals to +2. So now don't memorize, just understand. This lecture will be useful for you as a semester ready material. This would be a semester ready material for you, so that you can get a quick idea and a quick glance without memorizing or without saying multiple times, so that it is like a cheat code. So do remember like that only. It's not a class notes. My aim is to provide semester ready material to you, like that if you see this you can remember everything like what I have told you here. Okay, so how to identify LL? So how to identify the left. So the insertion path you have C, 30, 20 and 10. Now left to left, we travel left then left, therefore this is LL case. So you love this trick. So now LL rotation. So observe this. Now the middle node always becomes the new root. So you have to highlight this. So now 20, 10 and 30. So look carefully, 20 comes to the top, 30 moves to the right, 10 remains on the left. The tree becomes balanced. So for verifying 20, 10 and 30, so for calculating, left height is equals to 1, right height is equal to 1. So PF equals to balance factor is equals to 1 minus 1, that is 0. So balance factor becomes 0, therefore the tree is balanced again. Why middle node? So why did 20 become the root? Because 20 is between 10 and 30, therefore it can satisfy the BST property, left side smaller, right side greater, so BST property is preserved. So in exam, what you have to do is you have to draw the original tree, find the balance factor, identify the path, identify rotation, perform rotation, draw a final tree. This is enough for scoring maximum marks in your semester examinations, which will help you to gain more marks. So that you have to write like this stepwise, and you have to, if you correctly write the diagram and if you correctly written the theory part, that's enough. That's a piece of cake for you to get the marks in the examination, whether not only in JNTUK, any examinations. So your effort matters. So for examination type, I am going to give you a question like perform LL rotation 30, 20 and 10. Now solve it once again, so that you have to see it twice. Never guess the rotation, don't calculate balance factor blindly, don't forget BST property, don't make the root node wrong. So this is what you have to do for this examination. So I will give you some of the important questions right here. So like first question is, what is LL rotation? What is LL rotation? When LL rotation is performed, LL rotation is performed. How do you identify LL rotation? So like explain LL rotation with an example. Fifth question, so the question I have given, perform LL rotation for 30, 20 and 10. This question is enough. So another question, why LL rotation is required? Don't see clumsily about my handwriting. I'm just writing like I'm writing on the board. So how is balance restored? This is another question. How is balance restored? So these are the questions. So do practice well. Today we learned the first and one of the most topic of AVL rotations, LL rotations. So we understood why rotations are needed, when they're required, how to identify an LL case, and how to perform the rotation step by step while preserving the binary search tree property. In the next lecture, we'll continue with the remaining rotations, RR, LR and RL. So once you understand all 4 rotations, AVL tree insertion and deletion become much easier. If this lecture helped you, share it with your classmates, subscribe to Mr. Exams Professor, and continue learning with us. Bye guys, all the best for your examinations.